Yep, good. Right, let's get started. I'm going to be talking today about a project called Vert.x. It's a project I've been doing for the last year and a half or so. How many people here have actually used Vert.x? Can I get a show of hands? A few people. Okay. How many people have heard of Vert.x before? Okay, that's pretty good. Right, so the presentation today is going to be basically an introduction, a general overview of the project. So we're going to have a few code examples as well, so it's not completely boring. It's not really a deep dive talk. So first of all, I have to do the obligatory bio slide. So my name's Tim Fox. I'm currently employed by VMware. I've been there about a year and a half now. Before that, I was at JBoss for quite a long time. Some of the projects, open source projects I've been involved with, the creator of Vert.x. I worked on the RabbitMQ team for a while. And before that, I was basically ran messaging development at JBoss. So I'm the creator of HornetQ messaging system. You may have heard of that, which is basically the messaging system in the heart of JBoss AS. In the old days, I worked a bit on JBoss AS itself, and another project called MobiSense, which is a telco application platform. So I've been doing it for quite a while. So anyway, enough about me. Not here to hear about me. You're here to hear about Vert.x. So, okay, what is Vert.x? It's actually quite a difficult question to answer because Vert.x is actually a very general thing. Basically, it's a general purpose application platform. So you can use it for all types of applications. You can use it for business applications, or you might be using it for web applications. It's pretty agnostic as to what you use it for. And this is kind of a common feature of Vert.x. It's pretty much non-opinionated, unlike other platforms and frameworks. It runs on the JVM. Of course, that's why I'm speaking about it at this conference. As we all know, the JVM is the most sophisticated language virtual machine out there. And one common feature of Vert.x is it primarily provides asynchronous APIs at the core of Vert.x. And we'll talk in more detail about why we do it that way. Why do we choose an asynchronous approach? Because arguably an asynchronous API is harder to use than a synchronous direct style API. Another thing that's a kind of almost unique feature, I think, of Vert.x compared to other platforms and frameworks around today is it's truly polyglot. And by polyglot, of course, I mean it supports multiple languages. So you can write your Vert.x application, you can choose a single language, or you could choose a combination of languages and have different components of your application written in different languages, depending on the task you're doing, or depending on the skill set of your developers. Another common feature, simple but not simplistic. So the idea is we want to do things in the simplest possible way, but we don't want to take any power away from you. So we want you to be able to knock together stuff really, really easily, but really, really powerful, scalable stuff. And of course it's fun, so just having that power of doing stuff simply and powerfully is fun, right? And fun's important. So just extending the previous slide really, what is it good for? This is kind of the waffly first few slides at the beginning. Yes, general purpose application development. What I tend to find at the moment is a lot of people are using it for web applications. So in particular, the kind of new breed of so-called real-time web applications. And where does it fit? I mean, if you're trying to get a picture in your head of where does Vert.x fit in comparison to other frameworks and stuff around at the moment, platforms around at the moment. And one way of framing it perhaps is, let's say you're starting a new project and you're currently thinking of maybe using Node or maybe Play framework or Akka, then Vert.x is kind of working in that kind of area, right? So you may want to add Vert.x to your list as something to look at, a possibility for your project too. And of course we have some overlap with traditional app servers like Java EE app servers too. Okay, and a little bit of project information about licensing and stuff. So yeah, we're 100% open source. Who isn't these days? Well, we don't hear about the ones that aren't, but the code is licensed under ASL2, and the docs on the website are licensed under Creative Commons Attribute Share Alike. So it's all permissive license. GitHub statistics, for what they're worth, I'm not really sure you can read that much into them, but we're on GitHub right now. We're currently the 8th most watched Java project on GitHub, so it's actually pretty cool. I don't know quite what it means, but we're kind of ahead of some quite established Java projects that have been around for a long time. Tiny team, basically I'm the only person paid to work on it full time. We have some great contributors though. Without them, we would be nowhere. Okay, so let's go into the APIs a bit. So I mentioned before that at the heart of Vert.x there are some what we call the core APIs. And these APIs let you, what you code against in to write your Vert.x applications. And we provide several different services. This is not an exhaustive list, but I've kind of picked out a few of the most commonly used things. So we have APIs for writing TCP clients and servers, for writing HTTP clients and servers. The HTTP support also includes full WebSocket support, several different versions of WebSockets. And we have SSL, HTTPS support. The event bus. The event bus, I will talk in more detail about this. The event bus is really one of the most core features of Vert.x. The event bus is basically a lightweight messaging system at the heart of Vert.x. And it's what everything uses to communicate with each other. It's asynchronous messaging. We have file system support, so it lets you do all the kind of things you would expect to do with files, create files, delete files, append files, all that stuff. And the common feature of all these APIs, they have an asynchronous programming model. So a very basic asynchronous programming model in the sense of you set handlers and you would call back an event-based programming model. So the difference between, an asynchronous style and a direct synchronous style, in a kind of direct synchronous style, for instance, reading some data from a socket with a synchronous API, you would say socket.read, and your thread would then block until some data was available, at which point it would unblock and return. So while your thread is blocked, it can't do anything else, right? With an asynchronous API, you don't block, yeah? You basically provide a handler, give that handler to the system, and then sometime later, the system calls back your handler with the data. In the meantime, you can go and, do something else. So it's a kind of don't call us, we'll call you approach. Okay, very simple code example. This is basically lifted from the website. If you've been to the website, you'll have seen it before. This is basically a trivial functional web server written in JavaScript. Vert.x supports JavaScript, Ruby, Java, Python, and Groovy currently. We have somebody, Stuart Williams is currently working on Scala support. So hopefully before long we're going to have Scala support, which hopefully will be of interest to a lot of Java developers, and a lot of people in the Java world are kind of thinking of doing more Scala now. Also Clojure support. We have a community member currently working on Clojure support, and Clojure is really going places right now. It's a really great language, so that would be cool to have. But for this demonstration, I've done all my examples, bar one, in JavaScript. And I chose JavaScript because, well, it's less verbose than Java. It's easier to see what's going on. And I think it's pretty fair to say most developers here would have some experience of JavaScript. It's pretty easy to read, right? Okay, so let's have a look at this example. So what's actually happening? We are, it's pretty self-explanatory actually. We're creating a HTTP server and we're setting a request handler on it. And the handler is simply a function that will be called by the system when an HTTP request arrives. And when the request arrives, we're basically working out which file we want to serve from the file system. So if the request is for root, we're just going to serve index.html. Otherwise, we're going to get the name of the file off the path and serve that. It goes without saying you wouldn't actually use this in production. There are obvious security issues with this. I won't tell you what they are, but it's quite easy to work out. But just for the sake of brevity, I've used this example. So once he works out which file, we're sending back the file in the response. And let's actually see that in response. And let's actually see that in action. Okay, so let's go to a console. So Vert.x run, web server.js. So you run a Vert.x vertical by using the command Vert.x run. A vertical is just the piece of code. We call them verticles. So let's run that. Okay, and let's go to a browser. Browser open. Go to localhost 8080. Okay, so it's worked, right? There you go. There you go. Here's exactly the same example written in Java. As you can see, it's more verbose. There are at least 3 reasons for that. Java is not a scripting language, so you have to wrap everything up in a class to run it. So that adds extra verbosity. Secondly, Java is a statically typed language. There's type information there you wouldn't have on the page in JavaScript. And thirdly, Java currently has no support for anonymous functions or closures. So the handler, you have to wrap it up as a anonymous class. That's going to change in Java 8. In Java 8, there's something called lambdas. Lambdas are basically anonymous functions, so that will actually reduce the amount of verbosity in Java and make it a bit nicer to program with asynchronous APIs in Java. Right now, it's kind of awkward in Java. Okay, so I mentioned the word vertical. What is a vertical? A vertical is basically the execution unit of Vert.x. So that example we just saw, those last 2 examples, those are both verticals, or they're vertical. When they're running, they're verticals. Okay. So in a non-trivial Vert.x application, you would typically have more than one vertical. You would probably write your application as a set of loosely coupled verticals, maybe written in different languages, depending on what you're doing. You may want to write your complex stuff in a statically typed language, so you've got the benefits of static type checking. You may want to write kind of glue code stuff in a scripting language like Groovy or JavaScript, or Ruby or Python. And your application would typically be composed of many such verticals, all communicating by message passing. So they use the message bus to communicate with each other. Another feature of verticals is verticals provide isolation. So currently, when you run a vertical, the vertical instance running in memory runs in its own class, has its own class loader instance. So what this means is you can't do stuff like using static class members to share state. Right? Which means you can't, so it's avoid, because if you could use static class members to share state, then you're going to have multi-threaded access to shared state, which is a bad thing, right? Because then you've got to synchronize it, you've got to protect it, and then you're going to get into race conditions potentially, and deadlock potentially, all this kind of stuff. And that's what we're trying to avoid. So that's a vertical. Why asynchronous? Right, so I've already told you the core APIs in Vert.x are asynchronous. So why is that? Why do we choose to have asynchronous APIs? Because arguably, having a direct style API is easier to code against. It's arguably harder to reason with, kind of event-based APIs, harder to debug, etc. So the reason is really all about scalability. It's a feature of modern applications, and I think this is going to be even more true as we go ahead, that many long-lived connections are a characteristic of those applications. Those connections may be things like WebSockets, as WebSockets become more popular. Or they may be stuff like, in the Internet of Things, when we're going to have small devices embedded in everyday objects, and perhaps they're using MQTT or some other protocol that uses long-lived connections. So basically, your server, whatever it is, it needs to cope with many, many, many connections. And to do that in a responsive way, you basically, a blocking approach simply doesn't work because you need to serve those connections with a small number of operating system threads. And operating system threads are a precious resource. They have a certain amount of stack memory, quite a lot of stack memory, and there's context switching overhead. And you quickly get into law of diminishing returns as you increase the number of threads. So you basically need to serve a lot of connections with a small number of threads, which means you can't block. Because if you're blocking, those threads can't do anything else. They can't serve other connections. So it brings us to a non-blocking approach and an asynchronous API. I will actually talk a little bit at the end. We can get into the realm of continuations and promises, and I'll talk a little bit at the end about that, because the actual full picture is a little bit more complicated. And this brings us to the threading model of Vert.x. How many people here have heard of the reactor pattern? Okay, so quite a lot of people. You may have heard the popularity, of the reactor pattern has been most noticeable with Node.js. It's an implementation of the reactor pattern. Basically, the reactor pattern, what it is a very simple concept. You basically have an event loop which just spins around, and as events come into the system from the outside, Those events might be data being received from a socket, or data being read from a file on disk, or maybe a timer firing. The event loop spins around and it picks up these events one by one and then delivers them to any handlers that are interested in them. And it does it serially. So basically it's just an OS thread which spins around. Okay? So the advantages of this are A, everything's single-threaded, right? It's a single thread, so that makes it easier to reason about concurrency, because there is none. Secondly, you get less context switching, single thread. Disadvantage, it's a single thread, right? Servers generally these days don't have just one core. So in order to scale, you need to instantiate many instances of your server, yeah? And then you get into the issues of how to do inter-process communication between them, because they're all running in different processes. And then you've got the issues of you've got to put a load balancer on the front of them and somehow farm out requests between all the instances. And this is the approach Node.js takes. Vert.x is somewhat different. It is kind of reactor. It kind of implements the reactor pattern, but what I call it is the multi-reactor pattern. It's I've made that up basically. So what the multi-reactor pattern is, we have, instead of having one event loop, we have multiple event loops. And we typically match the number of event loops to the number of cores on your server. So theoretically, we can then utilize all the cores with a single process. And because the JVM has true multi-threading, this allows us to do that, unlike V8. So that's where we kind of differ from, say, Node. And with an event loop, obviously, one sort of golden rule with an event loop is you don't want to block on the event loop. If you block, you do thread.sleep, or maybe you use the JDBC API or some other traditional blocking API, or maybe you try and calculate a Fibonacci number, that's going to block the event loop, right? You don't want to do that, so that's kind of the golden rule. So in other frameworks, they may say that they're quite religious about event loops. They say you've got to do everything on the event loop. But that's kind of stupid, because event loops aren't a silver bullet. There are certain things that you might want to do that don't make sense to do on an event loop. So we need another solution here. So, I mean, for some types of work, event loops are great. For very short-lived stuff, for dealing with streams, they can be really quick. But they're not the best fit for everything. Examples are calculating long-running calculations that take some time. Don't want to do that on an event loop, because if you're doing that in an event loop, then you're blocking it, and that event loop can't do anything else. And then you get into this stupid game of having to split it up into little sections and do them on different routes around the event loop. It's a mess. Another example of the kind of things you don't want to do in an event loop is using traditional Java blocking APIs. Most APIs in the Java world are blocking, because that's kind of the way people have programmed in Java for a very long time. A good example is JDBC. In JDBC, you execute a query, then you wait for the results to come back. And while you're waiting, your thread's blocking. So you don't want to do that kind of thing on an event loop. So, Vert.x is a JVM system. We don't want to throw away these years and years of the ecosystem of Java libraries that have built up over years. We need a way of using those. So how do we leverage them? So Vert.x actually has a hybrid threading model. It does event loops, but it also lets you run stuff on a thread from a thread pool if you want. So you can choose, depending on what you're doing, you can choose whether you want to do it on an event loop or you want to do it on a thread pool. So we don't force you to do everything on an event loop and force you down this route of just crazy, you may have heard of the kind of farce behind the whole Fibonacci thing in the Node.js world about a year ago. If not, then you can probably Google it. So if you have work that, say, you want to use a JDBC API, then you can mark your vertical as a worker vertical. And then when you run it, Vert.x will say, oh, it's a worker vertical. I'm not going to run it in an event loop. I'm going to run it on a thread from a thread pool. And then you can tune your thread pool in much the same way as you tune your JDBC connection pool. And this allows us to leverage the huge ecosystem of Java libraries. And this is related to, I'll spend a few minutes talking about the concurrency model, because it's actually a really important thing in Vert.x. One thing that we've really tried to move away from is the kind of traditional Java-style, multi-threaded concurrency. It's actually a bit unfair to say Java-style, because it's not just Java-style, it's C++ style and C-style, and it's around long before Java, right? So, but what I mean by that is, the kind of concurrency where you have lots of threads running through the same code, the same state, using the same state at the same time. And this, It's the way people have, in the Java world especially, have program applications for a long time. And it introduces a lot of problems. I'm sure most of you are familiar with the kind of race conditions and deadlock. And as your application becomes non-trivial, you're going to have bugs in your program. It's very hard to reason about. So we're trying to move away from that kind of concurrency. So what we said is a vertical instance is strictly single-threaded. So when you're writing code in Vert.x, you never have to worry about, basically, you write your code as single-threaded at all times. So you don't have to worry about synchronize, volatile, locking, all this stuff. And what it means is you can basically wave goodbye to many race conditions that you would normally get with a traditional multi-threaded concurrency. So we think this is quite a big win. And again, this is related to scaling. So how do you scale a Vert.x application? If a vertical instance is strictly single-threaded, then a single vertical instance can only run on at most one core at any one time, right? But your server has more than one core, so how do you scale your application? So you have to scale it by creating more vertical instances. And that's exactly what you do. So you have these isolated vertical instances, and they use message passing to communicate with each other. Now you might be thinking, hang on a second, this sounds a bit like the actor model, doesn't it? If you're familiar with Erlang or Akka, or just from, you did computer science at university, you'll know the actor model. It is similar. Vert.x is not actually a strict actor implementation, but there are similarities. There are definitely similarities. The main difference really is actors tend to be very fine-grained, and most actor implementations allow you to create many, perhaps millions of instances. Vert.x vertical is a bit more coarsely grained. You wouldn't normally create so many instances. But there are similarities, for sure. So that's how you scale a Vert.x application, create more instances. And if your Vert.x vertical is a TCP or HTTP server, what we also do is a bit of magic. So we actually give you free load balancing as well. Because you might think, if I have a web server vertical and I just create 8 instances of it, then something still needs to load balance the requests amongst them, right? You get that for free with Vert.x, unlike other frameworks where you'd have to instantiate a cluster module or something like that. I'll show you an example, actually. So, if I do Vert.x run web server JS again, now when I ran it before, I just ran Vert.x created a single instance of the web server, so that would have used at most 1 core in your machine. But let's say I want to use 8 cores, right? Depending on how many cores you've actually got. So if I put 8 in there, I put minus instances 8, and it just does the same thing basically. So I can go back to my browser. Oops, let me just remove that. And, well, you see the same page again. You can't actually tell there are 8 instances running there, but trust me, there are. But you might think to yourself, hang on a second. How can you have more than one instance of a server running on the same port, on the same host, on the same machine at the same time? Because surely you get a port conflict there. So Vert.x is very clever here. It actually recognizes you're trying to run more than one instance on the same host and port. And if you are, then it will actually only create a single server socket, and it will farm out the requests amongst all the instances for you. So you get the load balancing for free, basically. Oh, and while I'm here, I actually was going to say earlier, when I was... let's actually run the Java... well, I showed you the Java example of a web server before. Here's the actual code, if you don't believe me. All right? Now let's just run that. So we do Vert.x run again, web server.java. Now, hang on a second, I'm running it, I'm specifying the Java source file here. I'm not compiling it. You might think, hang on, it's a Java file, you've got to compile it first. Not with Vert.x. With Vert.x, well, Vert.x can run class files if you want, but just to kind of save this compilation step, you can actually tell it to run Java files directly. So you're almost kind of treating it in, not quite like a scripting language, but getting towards that direction. And it'll just work. And let's go back to our page again. Yeah, page again. Yeah, so that was a brief aside there because I missed that bit out earlier on. So you can actually run Java files directly. So back to scaling. You get a lot of stuff for free. Right, so let's move on to the event bus. The event bus is I would say, probably the most important feature of Vert.x. It's the nervous system of Vert.x. It's the thing with which all the verticles communicate. When I say sending messages, they're sending messages over the event bus. Like most things in Vert.x, it has a very, very simple API. It's a lightweight messaging system. We support all the major messaging patterns: point-to-point messaging, publish, subscribe messaging, and request-response messaging. I won't explain what all those are. I imagine most of you have used messaging systems in the past, so you're probably familiar with those terms already. The things that you pass on the event bus, what are they? Well, you can pass simple strings, numbers, other primitive types. But what we recommend for structured data is to use JSON. And the reason we recommend that is Vert.x is a polyglot system, and JSON is well understood by all the languages we support. And in many of the languages, especially JavaScript, Ruby, Python, Groovy, there's very good support for kind of literals. So you can basically represent your JSON as literals. In JavaScript, you've got obviously an object literal maps to JSON directly. So basically, JSON is very easy to create, it's very easy to parse, it's very easy to read, for a human to read too. So that's why we recommend you use that when passing messages between verticals. It's not mandatory, it's just a convention. So if you don't want to use JSON, you can use something else. We just recommend it. Let's have a look at a code example with Event Bus. This is a trivial example. This is a single vertical written in JavaScript again. And basically what it's doing, at the top of the screen, you have a handler. We're defining a handler, which is just a function in JavaScript. And that handler will hopefully receive a message. And when it does, it's just going to log out, receive message, plus the message contents. Next, we're registering that handler on an address, against an address on the event bus. And then at the bottom of the screen, this Vert.x set periodic, basically that's setting a timer to fire every second. And when it fires, it's going to execute a function, and that function's going to send a message to the same address that we registered the handler against. So it doesn't take a genius to work out what's going to happen there. You're basically going to, hopefully every second, you're going to see received message displayed on the screen. So let's just try that out. Oops. Let me just move that up a bit. Right, so you have to go to a different directory. Vert.x run again. Event-bus.js. And there we go. Hardly surprising. It works, right? Not the most amazing example of the event bus. But that's in reality, you wouldn't be using the event bus to send a message from one vertical to the same vertical. You'd be using it to coordinate multiple verticals in the same JVM instance. But it goes further than that. You can actually connect multiple JVM instances running Vert.x on different parts of your network, all communicating over the event bus. So the event bus can cluster together. So you basically have this large distributed event space. So you can send messages exactly the same API, irrespective of where they actually are on your network. So you can create your application as a set of loosely coupled components written in whatever languages you want, living on different nodes of your network, all talking using asynchronous message passing, which is quite a powerful concept. Let's actually try that out, shall we? Okay. So, right. So this time we're going to. Actually, let me go back to the slide. Show you the actual code on the slide first. Right. So here's a distributed event bus example. It's exactly the same code as before. The only difference is we're going to split it now into two different files, two different verticals. We're going to have a handler.js vertical, which basically just has the handler part of the code. It's going to register a handler. And then we're going to have another vertical that's going to be running in a different JVM instance, which is doing the sending part, because a timer every second sends a message. So every second sends a message. So let's actually run that. Okay, so Vert.x run again. I'm going to run the handler in this instance. Now this time we need to tell Vert.x to look out for other Vert.x instances on the network so it can cluster together with them. So we just do that by saying -cluster. Okay, it takes a couple of seconds to start up. We actually use, at the moment we use Hazelcast to do some of the group management. It's going to be pluggable though. Right, so where are we here? So we're going to run the sender side over here. Vert.x run sender.js. Now this time I'm going to put cluster as well. Now because we're running both the instances on the same machine, we don't want a port conflict, so we're going to have to tell it to use a different port as well. But you wouldn't have to do that if you're running on a different node of the network. Okay, let's give it a couple of seconds. There we go. So it's sending messages. These are two different JVM instances, and it works. It's exactly the same API. So this basically, like I said before, lets you write your application as a set of loosely coupled components, and I'm kind of going to stress this point throughout, in different languages communicating on the event bus. But it goes further. The event bus can also extend into client-side JavaScript running in the browser too. And again, it uses the same API. So now you imagine you've got this event space made up of multiple server-side nodes where you can have your server-side part of your application, each doing different bits, different components doing different things, but now also talking to browsers. And you can have browsers talking to other browsers, and browsers talking to servers, and servers talking to servers. All completely transparent as to where they actually exist. So this kind of gives you quite a solid basis for creating so-called, real-time web applications. Let me just give you another example. Let's actually try this. So let's just Control-C these two processes. So let's run the server. Actually, let's flick back to the code 1 second. I'll show you the code again. Right, let's actually try this in a browser. So again, exactly the same code, but we're just putting it in a different place. We're just running it in a different place. So we're going to have on the server side, we're going to have the sender still, sending a message every second, but this time we're going to have the handler in client-side JavaScript, running in Chrome. Okay, so let's run the server. Oops. Now this time we just want to open a browser. We're going to open the JavaScript console because we're doing console.log, so you're not going to see it otherwise. And let's just refresh that page. There we go. So it just works irrespective of where you're actually running it. It's the same API. This is actually a very powerful concept. Right? So you can write your application. You don't have to worry about the transport between the client and the server. That's done for you. Yeah? You don't have to worry if WebSockets are supported. You don't have to worry about REST, all that clunky stuff. Right? It's just simple event bus API. Oops. All right. Yeah, so that's the event bus. You may be asking yourself, the actual transport between the browser and the server, how is that actually done? And what we use is there's a library called sock.js. How many people have heard of sock.js? Okay, that's cool. How many people have heard of socket.io? Okay, so slightly more socket.io, which is unsurprising because that's what they use in the node world. So it's a kind of similar thing. Sock.js is actually a project, another VMware project. And what it does, effectively, is it provides a WebSocket-like API to you in client-side JavaScript. But that API works whether or not you actually have WebSockets available in your browser. Maybe you're running an old browser version that doesn't have WebSockets. Or maybe you're running on a network and you've got a corporate proxy which doesn't like WebSockets. So it just works. You don't have to worry about, all those things. And what it does, it will fall back to, if WebSockets aren't available, it will fall back to another transport. It supports many transports, like, different types of polling and streaming and stuff. And you can check that out on their website. Okay, so where does this bring us? I said before, Vert.x is a very general purpose system, but it's very good for real-time web applications. And when I say real-time here, I'm talking about the kind of modern webby definition of real-time. And if you've been work in this area for a long time, you know that there's a computer science definition of real-time, about hard real-time and soft real-time, which is all about guaranteed response times. We're not talking about that. We're talking about this kind of modern definition of real-time, which basically just means pushing stuff to browsers without having to refresh the browser. Yeah, actively having a communication channel open with the browser. So, as you can see, with this event bus, you can basically concentrate, on sending messages to your server-side components or browser nodes. You don't have to worry about the details of the transport. And so it makes it very good for the kind of these, kind of applications, like mobile applications, online games, this kind of stuff. And actually, we have a few users already using it for online games at the moment. So it's quite a good fit for that kind of thing. And on the client side, Vert.x is totally agnostic as to which toolkit you use, right? So you can use whatever you want on the client side. We just provide a very simple JavaScript API you can use from whatever stuff you use on the client side. So if you're using, say you're creating a kind of one of these modern MVVM, MVC client-side JavaScript frameworks like Ember.js or, Knockout.js or Angular.js, this kind of thing, then you can just use it with that. It's up to you what you use. We don't preach about that. Okay, the other important feature of Vert.x I want to talk about a little bit is the module system. So this is a fairly new thing in Vert.x. So with the module system, basically you can package up your application or smaller reusable components into modules. And the modules basically encapsulates all your dependencies and all that stuff and allows you to deploy your application or components in a very simple way. So basically, it's a fully fledged module system. Modules can contain code in any of the Vert.x languages. We have a public module repository that hasn't been around very long, so we haven't got a huge amount in there yet, but we're basically hoping to grow it. So the idea is you can create your modules, you can place them in the module repository, or you can host your own module repository internally in your network if you want. The idea here is we want to encourage an ecosystem of Vert.x modules. So you want to basically get the community to engage and to share stuff, right? Because the core APIs, we don't envisage them changing much over time. New functionality, we're not going to add much to those core APIs. We want to keep them very basic, very low level and simple. The idea is we want most new functionality to be in the form of modules that work on top of that. And it's pretty much early days. And right now, here are some examples of modules we already have. A MongoDB module, Redis, AMQP, and various other things. Some of these have been written by us, some have been written by members of the community. We want to kind of really encourage this. So very briefly, what is a module? Again, kind of back to the core value of simplicity in Vert.x. Really, a module is just a directory which contains at least a text file called mod.json, which is basically a JSON descriptor file, which in many cases can be completely empty. It also contains, obviously there's scripts and classes, Java source files if you want, that make up your module. It can contain jar dependencies too, and modules can include other modules. And one interesting feature about Vert.x modules is they're resolved at runtime, not at compile time. So if you write a verticle which references a module like the MongoDB persister, then the first time it hits that bit of code, it'll say, oh, have you got that module installed already? If you have, it'll use that. Otherwise, it will contact the public repo, download it, install it, and run it. Yeah? So in many cases, if your application is using a whole set of modules, you don't have to package them up in advance. You can literally have a very, very small kind of bootstrap script, deploy that, and then it will just download all that at runtime if you want. So that's a pretty cool feature. Okay, so I think I kind of gave an introduction of the main features and the kind of main philosophy behind Vert.x. What does the future hold? We want to concentrate, we want to basically expand the language support. I've mentioned before, the two languages we really want to concentrate on next are Scala and Clojure. Hopefully we'll have Scala support before too long. Stuart Williams has been working on that as we speak, and we have a community member working on Clojure. Management. Right now we don't have any built-in management monitoring support, so for running Vert.x in production this is kind of important for ops guys. So again, Stuart Williams has been working on management support, which includes a nice GUI console, so you can manage your Vert.x instances. Another really important thing we need to spend more time on right now is the whole developer experience, which includes kind of good IDE integration, IDE testing, and all this kind of stuff, Maven integration, Gradle integration. So we have a really kind of seamless developer experience. That's definitely a priority to work on next. And there's two other kind of interesting things that I kind of touched on earlier, which relate to the nature of an asynchronous programming model. I said before, arguably, programming with handlers, when you have a lot of handlers, a lot of streams going on, it can be sometimes quite difficult to keep track of what's going on. The control flow is not always so obvious as when you're using a direct style approach, using synchronous APIs. So there are two kind of approaches you can take to solve that problem. One approach is to basically provide a kind of promises API, which a promises API is basically abstracting out the concept of asynchronous actions and allowing you to compose them together in different ways, using a nice sort of, a nice API. That's one way of doing it. Vert.x actually did have a promises API way back, but I got rid of it because it wasn't really up to scratch. So, and the other issue with promises is Vert.x supports multiple languages, and a promises API will be very different depending which language you're using it in. If you're using it in a functional language, it's going to be very different to a non-functional language. So it has to be written very idiomatically for the language. So it's actually a lot of work to do this, because it wouldn't just be one API we're writing, maybe writing 6 or 7 APIs. So we need to look into that. There is another way of doing this. Another approach you can take is not to use the promises API, but somehow try and use a direct synchronous style API. So we could have on top of the Vert.x core APIs, effectively a logically blocking API, but a blocking API that doesn't actually block operating system threads. And that is possible using something called continuations. And you may know continuations from computer science. Continuation is basically a way of taking the state of your stack and storing away and sometime later jumping back to it. And there have been a few frameworks in the Java world that have done this over the years, like JavaFlow and Killim and various other things. Problem with continuations is it's hard to do it in a scalable way, but it's definitely something to look at. The advantage of doing it a continuation approach is you don't have to write 7 different promises APIs. So this is something we're going to be looking at. We're not really sure which way we're going to go at the moment, but it's something we're definitely going to look at more going ahead. And that's pretty much it. So just to summarize, Vert.x, Polyglot, you can use the language you want to use. You can basically compose your application as a set of different components living on different nodes of your network and in the browsers too. We have a very simple concurrency model, so you don't have to worry about whole classes of race conditions disappear. We allow you to leverage the existing Java ecosystem, so you don't have to rewrite the wheel and rewrite everything in an asynchronous style. And we have this powerful event bus, which allows you to connect up all different parts of your application in a loosely coupled way, and a powerful module system. So there we go. We believe Vert.x is the platform for the new generation of polyglot web and enterprise applications. We really want, please get involved. We have loads more to do. We have a huge to-do list. The main issue we have right now is the team is very small. A lot of potential there. Vert.x is growing up. It's I suppose it's going into its teenage years now. It's kind of out of its nappies. It's not a child anymore. Come and visit us in our Google group. That's where most of the discussion takes place. Everything happens on GitHub in terms of code, so please get involved. We'd love to have you helping out. And that's basically it. So thanks very much for listening. Any questions? There's one over here. Yes, so the question was, do the modules communicate via messages? So basically, the module can contain many verticles, contain one or more verticals, and verticals always communicate via messages. So yes, the answer. There's another question over here. Right, so the question was, is it possible to combine Vert.x with a Java EE application? I've never tried it myself. I would have to look into that. I mean, Java EE applications generally provide, have their own threading model and stuff. You sort of have to figure out whether that's compatible with the Vert.x threading model. So the answer to that is I don't know, to be honest. I see. So the question is, so could you perhaps connect it up via the event bus? Could you connect up a Java EE app server via the event bus to Vert.x? Thinking about it, one way you could do that in the Java EE world is perhaps writing a JCA adapter, which basically talked to the Vert.x event bus, and then you could basically send messages to Java EE via that JCA adapter, I imagine. That would be one way of doing it. And a question over in the middle. The question was, is there a template engine? Right, so this is actually a good question, because Vert.x is very much, it's quite a low-level thing, right? So we are totally agnostic about how you generate we don't provide a template engine, basically, but you can provide your own template engine on top. It's quite a low-level thing, Vert.x. So what we envisage happening as we go ahead, people will create modules which have things like template engines in them. So if you want to use a certain template engine, you'll just reference that module will hopefully be in the public repository. You'll reference that in your code, and then you can use that template engine. But Vert.x in the core, again, the core is very low level, that TCP, HTTP, event bus, that kind of stuff. We don't envisage putting a template engine at the core level. It's quite a low level kind of thing. And a question, the guy in the red t-shirt. Okay, so the question is, how mature is Vert.x? Is it ready for production? We do have people using it in production already. I don't actually keep I should start keeping a list of this. It's a question I get asked quite a lot, and I don't actually have a list. But if you go to the Google group, you'll hear the various people, people post messages saying, oh, we're successfully using it in production. We find right now quite a lot of people are using it for kind of like this real-time web applications, like online games, that kind of stuff. So it's getting fairly popular in that area. Is it mature? It's how long is a piece of string, right? So it's been around for a year and a half. It's obviously, I would say it's kind of like in its teenage years, Vert.x. So we're kind of getting to a stage now, we really want to kind of bulletproof everything and get the whole developer experience worked out. So we're kind of, so yes, I think you can use it in production, but the whole developer and production experience will improve going ahead. Right, so the question is, will we keep the code base the same? So I imagine what you mean, we don't want to produce incompatible changes in the APIs, right? Yeah, so up to now, we've kind of, because, we're in a more sort of embryonic stage, that we could change the APIs more readily. Now we're getting to a stage where we're much more careful about changing APIs because we don't want to introduce incompatible changes. So we have to start thinking about versioning and stuff like that. One possibility is we're actually going to move out the core itself into a module itself, and then you'll be able to have different versions of the module, depending which versions of the API. So we could version it that way. But that's kind of up in the air at the moment. But for sure, we're going to be very careful about making changes to the core APIs. We want to keep them pretty static, so we don't have too many of those kind of problems. Question in the middle there. Oh, okay, so what libraries, what dependencies we have? We use Netty for basically a lot of these socket and HTTP support, we use Netty. I have a very long history with Netty. I worked with Trustin Lee, the author of Netty, when I was back at JBoss. And Netty, I was basically the first user of Netty in HornetQ. So we've worked very, very closely together with the Netty team. So we use Netty a lot internally for a lot of the non-blocking I/O, basically. And question at the front here? Okay, so the question is, have we done any performance tests comparing to other frameworks? No, we haven't really got any rigorous performance tests as yet. Right now, we're not really concentrating on performance as a major goal, and I'm more interested in basically getting a developer experience sorted, getting it very stable, and getting the functionality there. Because, I used to work in messaging systems, and I worked a long time, doing very high performance, millions of messages per second. And the reality is, not that many people need that kind of performance. Everyone likes to say, oh, my system can do, 500,000 messages per second. But it's kind of like, so what? No one, very few people actually use that. So it's not actually as important. I mean, it's a few people in financial services, stock exchanges, they do that kind of thing. Not many other people do. So actually, it's kind of, it's something we are going to concentrate on. I did do a few basic benchmarks you might have seen versus Node.js. There's a bit of controversy about that. You can see it on the web. We basically, we were quite a bit faster than Node.js. But we haven't really spent a lot of time optimizing as yet. But we are fast. But yeah, it's not a major goal right now. Okay, so some questions at the back. There's a guy right there. Yeah, so the question is which language engines do we use for the different languages? So yeah, we use JRuby, well, unsurprisingly, JRuby for Ruby. We use Jython for Python. We use Groovy, Java obviously, Rhino for JavaScript. They've all worked out really well. Rhino actually has done really well as well. People have kind of in the past compared it to V8 and said it's really slow, but actually that's not my experience. Yeah, so, and then going ahead, obviously Scala has very good interoperability of Java, so that should be quite an easy one to integrate. Yeah. More questions? There's a question at the front here.
Does the core HTTP support as functionalities of security or connection of the client?
Right, so the question was, the HTTPS support, do we support client certificates and that kind of stuff? Right, okay, so we don't, again, in the core, we don't provide any support for authentication or authorization in the core. However, there is a module that provides basic authentication support. And there's actually if you look in the distribution, there's an example web application, example real-time web application. And that uses that module, so you can actually have a look at that in action. For HTTPS, we do support full client and server-side certificates, so it's full HTTPS support. Yeah, basically. And so a question just over there. Sorry, can you say that again? Okay, so the question was, what's the bandwidth for the event bus when it's extended to the client? So this really depends on which protocol is being used. So I mentioned before we use this thing called SOC.js. The SOC.js will select an actual transport protocol depending on the capabilities of the network. So if you're in an old browser, it won't be using WebSockets, it might be using polling or whatever. So you're probably going to have a lower bandwidth using polling than you would with using WebSockets. Yeah? So it depends on the transport you're using. I mean, typically, WebSockets, if you're using WebSockets, you probably get the best bandwidth, because WebSocket is basically just a TCP connection, right? Yeah, so you should have a very good bandwidth. I can't put an actual figure on it, because that depends on your network and your browser and your server, but it depends on the transport that's being used. And another question at the front here? Okay, good question. The question was, what was my first reason for starting the project? I don't know, actually. I was kind of, at the time I was working with the RabbitMQ team, and I was kind of thinking about, I'd looked at Node, and I thought, this could be done better. The JVM is a better, in my view, a better language virtual machine. It has garbage collection support is excellent, it's true multi-threading. And I thought, what if we could do something kind of superficially similar to Node, but without Node's failings, in my view, most failings. And if we could extend that to multiple languages, and that's really where the idea came from. And I discussed it with various other people, and yeah, I kind of went for it. And then basically I was working on it part-time while I was working with the Rabbit team for quite a while, and then as it got more attention, I kind of managed to persuade management to let me work on it full-time, and it kind of went from there. A question over there? Sorry, can you say that again? Persisting, okay. Right, so the question is, are there any plans to provide persistent messaging support in the event bus? So right now, it's all transient messaging, which makes things a hell of a lot easier to do, okay? I don't think we'll actually add persistent messaging to the core of the event bus, but again, it can be something that's provided by a module. And actually, we already have limited persistent message support in a module. We have a module called work queues, which basically allows you to implement the work queue pattern. So this is kind of like an order processing pattern, where you may have many workers pulling jobs off a work queue and then executing them. And you may have like a pool of workers pulling these jobs off a work queue. And obviously, the order, you want that to be persisted. And that actually does already support persistence. Currently only with MongoDB, but we can make that pluggable. But that kind of thing, yeah, again, like this is a common pattern. We want to implement most of this stuff as modules rather than in the core of Vert.x. Any more questions? Oh, there's one question over there. The full code for the server? Okay, yeah, well, the code on the client is literally just that bit of, let me just, so the question is, can you actually, the code, the demonstration that we showed with the handler running in the client-side JavaScript, can we see the code for that? Right, so it's actually in, which directory are we in? Event bus, yeah. So if I do this index HTML, there you go. Oh, no, sorry, the wrong one. Yeah, there it is, yeah. So it's just literally a blank page. You're including the Vert.x event bus library, and then you're literally just making a connection to the server, event bus connection, and then you're just providing, basically registering your handler on the event bus. The server-side code, you have a certain amount of boilerplate to set up the sock.js bridge, which is just the same every time. Okay, so you're creating the HTTP server, then you're serving the static files. You're creating the sock.js server, that's it. And then it's just this, you're just sending the message every second. It's very simple. That's it. Okay, the question kind of over there. Sorry, can you speak up a little bit? No, the question was, is there an equivalent to the connect middleware stuff you get in Node.js? The answer is not as yet, no. Although it has been raised, that question has been raised a few times on the Google group, and we've got a few people interested in doing something similar. So hopefully we'll end up with some modules before too long that do something kind of similar, so you can plug your stuff in a similar kind of way. Right, more questions? Okay, so that's it. Thanks. Thank you very much for coming. I hope that's told you a little bit more about Vert.x.